Okay, so let's go ahead and pick up where we left off, which is example 2. Perfect. So reminders, we know we're looking at the height of AP Statistics students at Rancho San Juan. Yeah, we know that that height distribution is approximately normal with a mean of 64.8 inches and a standard deviation of 3.8 inches. Right? We found that when we started these notes. Okay, so first thing I should do, I'm solving a proportion, which is another way of saying percentage. I'm solving a percentage question for a normal distribution. What comes first? The graph. If we're doing a table, ultimately I will need a z-score, but I should start with a picture and a probability statement. Good. So we know what the normal curve looks like. We know for x values, we've got our mean of 64.8 in the middle. We've got 3 standard deviations out in either direction. We've labeled them in all the other pictures. I'm not going to take the time to do it now because we need to get through this quickly. But we know what those labels should be because we did them yesterday in example 1. So they should be on the line above. Yeah? I'm going to write our probability statement. And this question is asking us to find the proportion of AP Stat students at Rancho San Juan that are taller than 70 inches. That is what we are asked to find. What else do I need in my picture? Very good. So mark the boundary value or boundary values, shade the area of interest. Good. So our boundary value is 70. If I remember, that first standard deviation above the mean was 68 point something, and the next one was 70 point something. So I think that 70 is sitting right about here-ish, between 1 and 2 standard deviations above the mean. I see some nodding, yay. And x greater than 70, is that a left tail or a right tail? I see people pointing to the right. Good. Very good. So I want to know what that area is. That represents the proportion of students at Rancho San Juan in the AP Statistics program that are taller than 70 inches. We have a choice. We can do the table. We can do the calculator. I'm going to do the calculator. 1, because it means I don't have to convert to z-scores. 2, because that calculator is your friend in terms of speed on the test. So, on a calculator, what buttons do I press to get to the function I want? Second vars, very good. There's only 2 combinations of buttons we're really using. Stats, and then second vars, which takes us to distribution. Those are our 2 menus. Good. And in the second vars menu, what function do I want? Normal CDF, very good. Normal CDF takes a data value, spits out a percentage. It's going to ask for a lower bound to our shaded area, an upper bound, a mean, and a standard deviation. And when they talk about lower and upper, they're talking about the shaded area in my picture. So looking at my picture, where is the lower edge of that shaded area? 70, perfect. Where is the upper edge? Infinity, very good. On my calculator, how do I approximate infinity? Yes, gold star, very good. The biggest negative positive number in this case I can think of, 1E99. E is not the letter E. It's the E for scientific or engineering notation. Second, comma. So 1 second, comma, 99. Good. Mean and standard deviation we have from our distribution. Yes, Katie? I'm sorry. So the E is engineering notation or exponent, because what we're saying when we write this is we're saying that it's 1 times 10, and then the exponent on the 10 is the 99. Right, so this E is giving us the exponent on a power of 10. Yeah. Yeah. So it's your calculator's way of doing scientific notation. Mm-hmm. Mean and standard deviation, 64.8, 3.8. If you run that on your calculator, what do you get? 0.08. And then can you give me 2 decimal places? 5, 5, 5? 5, 6. 5, 6. Good. You'll notice z-scores out to 2. Yeah. Probability, percentage, proportions typically out to 4. Because traditionally, that's how many decimal places that z table goes out to, is 4 decimal places. So 4. Good. If this were the AP exam, what else would I include here? A statement or a sentence. Very good. I would interpret that number. So my answer would be 8.56% of AP statistics students at Rancho San Juan are taller than 70 inches. You need to restate in words what that thing you just calculated in your calculator represents, because that's where the statistics is happening. All of this was calculator math. I didn't do anything but put numbers in. I need to demonstrate I understand what's coming out of the calculator. Yeah? Yes?
I believe my calculator is set to like a rounding sign, so like my answers they always rounded to be the exact value.
So let's check your mode setting, and you'll notice that it says float. Yours are set to round to 2. If you leave it at float, it should fix that.
Okay, thank you.
Mm-hmm. Good. Okay, questions on the second example? No, good, okay. Next one says, find the proportion of AP statistics students at Rancho San Juan that are between 63 and 68 inches tall. 63 and 68 inches tall. We're going to go faster. Same process. I'm drawing my normal distribution. Labeling my mean, going out 3 standard deviations in either direction. If I hadn't done this already in a previous example, labeling those hash marks and writing my probability statement. So I want to find the proportion of AP statistics students that are between 63 and 68 inches tall. What do I do next? Boundary lines, very good. So 63 is pretty close to the mean. It's within 1 standard deviation below. 68 is a little bit below that first standard deviation above, because this was 68 point something, so right about here. And I see nodding. Good. So that's my area of interest. And I know something about that area. I know 1 standard deviation below to 1 standard deviation above should be what percent of my data? 68. Very good, Cami. Yeah. I'm within 1 standard deviation on either side. My answer is going to be smaller than 68%. Should be smaller than 0.68. If it's not, something went wrong somewhere. Good. We like 2 boundary questions because then I don't have to worry about infinity. When I go to do normal CDF, I have my lower and my upper. My lower is the 63. My upper is the 68. What did you get?
I got
0.482 what?
227.
227, so 23, I think. And I get a yes. Very good. Very good. Once you understand the calculator commands, the worst part of this is all the writing you have to do to support it, right? Because the calculator commands, when you're doing them over and over again, it's those same button presses, right? I need to encourage you at this point in the school year not to get lazy with your writing. Yeah? It makes the difference between a 2 and a 3 or a 3 and a 4. You need the picture. You need to label all your calculator inputs with words, not with symbols. You need to include a sentence with every number answer you give me, right? The proportion of AP statistics students at Rancho San Juan that are between 63 and 68 inches is 0.48. Yeah, it doesn't have to be complicated. Restate the words in the question, slap a number on. Yeah, but you need to give that statement. Okay, questions on how to find percentages or proportions? Yes.
Since all of these examples within the same data set, you mentioned that because you wrote the deviation values in your first normal distribution graph, do you have to label it for every single example you're using with the same data set, or do you just need to label the mean?
That is a great question. So if the example in your FRQ is one big question and it's all pulling from the same data set, a single labeled distribution and then doing what I did here should be okay, as long as it's very clear it's the same distribution each time. They understand that there is a time crunch on this test. So as long as it's on your page somewhere that you understand what the picture looks like, you should be fine. Yeah. It is important that if you switch distributions halfway through the problem, then you have to relabel the new. Right, or if you all of a sudden transformed your data by doubling it or adding 5, that's going to produce a new picture and you'll have to relabel everything. Yeah. No, that was a good question. Other questions? No. Okay, so the last thing we really need to talk about today is how to go backwards. If I know the proportion of students, can I figure out the boundary value that sections off that proportion from the rest? And most commonly, this comes down to finding percentiles. Remember that percentiles are measuring how much data is at or lower than my value. So if I'm at the 75th percentile for SAT scores, I did better than or the same as 75% of the students who took the test. Yeah. And the question is, now that I know that I'm at the 75th percentile, can I work backwards and figure out what my SAT score is that got me to the 75th percentile? That's what we're doing. Just like with finding area or proportion or percentage, we can do it two ways, table and calculator. Yeah, we'll start with the table. Some of this is going to feel familiar. You'll notice the first step, draw a normal distribution, label it, shade the area of interest. Yeah, that's still the first step. Get the picture on the paper. Mark the boundaries, right, of this area. If the area is not in the left tail, turn it into a left tail problem. For example, I'm going to scooch you over here a little bit. If I was asked a question about the upper 25% of students, well, the upper 25% of students would be the top 25, would be up here. The data table, as we learned last time, only does left tails. It doesn't know how to answer that question. I need to know what's to the left of my boundary, not what's to the right. I need to answer that question because that's what I'm going to look up in the table. Out of curiosity, if I want the boundary value for the upper 25%, what's the lower tail? Louder. 75, yeah, because it's 100% for the whole curve, right? So this would be 75%, and that's what I would look up in the table. Turns out we're going to do that same process for a calculator too. Yeah, good. Once you know the area in the left tail, we're going to look for that by searching the center of the table for that area. And if you remember from yesterday, we had z-scores along the side. We had z-scores along the top. We looked for where those met, and it spit out an area. Now I'm reversing that process. I'm looking at the middle of the table for my area. When I find it, I read over and up to find the z-score that goes with it. And we're going to do one together so you can see it. The catch: I don't want a z-score. I want a data value. I want to know what my actual SAT score is. So I have to reverse the z-score calculation. And we do that using the formula for z-scores. We know z-scores are data value minus mean over standard deviation. We solve that for x. We solve that for the data value. That's 2 steps of algebra. 2 steps of algebra. I need to undo the fraction first. How do I undo division? Very good. So we're going to multiply both sides by sigma. That's going to get rid of the fraction problem. Now I have x minus a number. How do I undo that subtraction? Yep. So plus mu. Those guys cancel. And you will notice what I have here is what I have here. Z times the standard deviation plus the mean. So it's a little bit of algebra. It's still the z-score formula. I've just solved it for x. The downside: this is not on your equation sheet. You have to remember how to do that algebra. If you are bad at remembering formulas, the calculator method is probably the best bet. If you're good at remembering formulas, the table might be faster for you. Yeah? Okay, let's look at the calculator method and then we'll do both. So calculator method starts the same way. You should draw the picture. You should mark the areas. But then you're going to grab your calculator and press second vars. And you want command number 3, which is inverse norm. What does the inverse norm ask you for? Area. Asks you for 4 things, yeah? So inverse norm is going to ask, what is my area? What is my mean? What is my standard deviation? Where is my tail? Left, right, or center? And I'm going to give you a caution before we do some examples. I would strongly recommend that you turn every problem like this into a left tail problem, just like you would if you were working with the book, and never muck with that tail setting. And I say that for 2 reasons. First, if you are looking at a distribution of data where the mean is not 0, bless you, and the standard deviation is not 1, sometimes those center and right tail commands give you the wrong answer. Calculators are not smart. Yeah, we build up errors in the memory the longer it runs. Sometimes you get boo-boos. The left tail almost always is correct. It does. The calculator is built to do left tail integration very well. Doesn't do so well with the right and the middle sections. The other issue is the other distributions we're going to look at this year only do left tails. So if we practice it now, that will be old hat when we start learning about other distributions later, because every other distribution will only do left tails. Yeah? So again, strong recommendation to just do everything to the left. Okay, we're going to do one example with the book and one example with your calculator. I need one person from every table to go grab 2 books from the bookshelf. And hopefully we remember from yesterday where to find the data tables. Yeah. Good. I see tables with the book open to the correct page. T0, T1. Yes. Like, get your attention back up front. Kick him under the table. Don't be quiet. All right. First step says find the height that corresponds to the 75th percentile of heights at Rancho San Juan. AP Stats. First thing I do, make my graph. Yeah, draw our normal curve, label our normal curve. We know how that works. Nope. Somebody should check if I did that correctly. I think I did. I'm not 100% sure. Subtracting 3.8 is hard in my head. Yay! Yeah, I can do math in my head. Except I can't hold my pen and be happy at the same time. All right. So next thing, I'm looking for the 75th percentile, and I need to figure out where that's going to lie. So looking at my picture, I know that one standard deviation out in either direction is 68%. Yeah? Empirical rule. And if I put dividers up there, I also know, yes, 52 should be a 3.4. Thank you. Oops, that's not helpful. It's so close. Very close. Okay. If I've got 68% in the middle, how much do I have left for the tails? The total is 100. 32 gets cut in half. $18 and $16 are definitely not the same. You know that. You can vote at 18. You cannot vote at 16. Not the same. Good. 16 plus 68. Without a calculator, I know that's bigger than 75. So I am bigger than the mean, which is on my halfway point, but I'm less than one standard deviation above. So that's going to help figure out where I put my boundary. I know my boundary is somewhere between the mean and one standard deviation away. meaning I should get a decimal answer for my z-score when I do this. And I'm shading to the left because percentiles are data values at or less than. Less than is to the left. So that area is 0.7500. 75% is 0.7500. And what we are going to do, since we know that we're sitting to the right of the mean, will my z-score be positive or negative? To the right of the mean, positive or negative? Positive, value's bigger than the mean, yeah. So I'm looking on the positive half of my standard normal table. Positive half, I'm looking in the middle for numbers that are around 0.75. So I'm going to give you a second, and you're looking for numbers around 0.75. There's going to be one a little bit bigger and one a little bit smaller. And as I've done this already once today, I have found them. I will give you a second to find them. Those who found it, which row are we in? So I'm going to go with the 0.6 row. And then which two n values sit on either side of 0.75? 0.07, 0.08. Very good. Because one is just a little bit less than 0.7486. One is a little bigger than 0.7517. 0.75 sits halfway between. I am going to use a z-score halfway between, because 75 sits between those two percentages. So I'm going to use 0.675. Except why is that blue? From the data table, we were in the 0.6 row. The percentages on either side of 75% were 0.707 and 0.08. I want a number halfway between. Here comes the math. That's a z-score. I want a height in inches. I need to convert. So I know height in inches is z-score times standard deviation plus the mean. We just found our z-score, 0.675. We know our standard deviation for height is 3.8, and our mean is 64.8. And on your calculator, what do you get? 67.365. 3.6 would round up to 4, so I'm going to round up to 4. 67.4. Can I get confirmation? I see some nodding. Good. Very good. 67.4 what? Inches. Very good. We were measuring height. Yeah. And I wouldn't stop there. I'm going to attach units to my answer, and then I'm going to write a sentence, right? The 75th percentile. I will write this one out for you. For height, and what were we measuring the height of? Yep. For height of RSJ stats students is 67.4 inches. Or 67.4 inches is at the 75th percentile of height for RSJ stat students, one or the other. Wording from the question, answer from our calculations plus units. Yeah. Yes. No. Yeah. They wouldn't dock you if you did, but no, they don't expect you to get all nitty-gritty about rounding. They know you rounded. Okay, we're going to do the next one with our calculator, so you can see the calculator method. I'm going to scoot you out here. Maybe. All right, next example says, find the heights that correspond to the top 10% of heights at RSJ. So first thing I do is draw my picture. I am not going to label the rest because I just did the same picture in the problem above, right? Save time. Top 10% of heights. I need to think about where that sits. We know that one standard deviation out is 16. I know that 2 standard deviations out is about 2.5. Because 2 standard deviations is 95. That's half of 5 in each tail. That's 2.5. So I'm closer to 1 standard deviation than 2, and I'm on the positive side. So I know my boundary is sitting somewhere here between 1 and 2 standard deviations above. That's the data value I want. And I need to know whether that top 10% is a left tail or a right tail. It's a right tail. Very good. With confidence, Vanessa. Yes, very good. I'm going to shade this way. And I know that regardless of table or calculator, I do not want a right tail. I want a left tail. So I need to know if this right here is 10% or 0.10. What is the area to the left? 90% or 0.90. Yeah, good. Area to the right is 10%. Area to the left must be 90% because the whole curve is 100%. Good. So to find our x value with a calculator, we're going to use the inverse norm calculation. Yeah. We're going to write out what it asks us for. So it asks us for an area. What area should I be using? 90, very good. And your area needs to be in decimal form. If you put a whole number in there, it is going to throw a tantrum because there is not more than 1 under that curve. Yeah, needs to be in decimal form. It also asks for mean and standard deviation. We know that. And then the last thing it asks us for tail, and we're going to leave that set to left. Left makes us happy. I'm going to give you a second to run that on your calculator. And I am going to have Anna Jade give me the answer when she gets it. .66, so 69.7-ish. Can I get a thumbs up if you agree? I see thumbs up popping up around the room. Very good. Very good. So the lower boundary, the smallest height that is part of the top 10% of tall people in AP Stats here is 69.7 inches, or 5 foot 9.7 inches, just shy of 5'10". Yeah. Okay, I'm going to give you guys a challenge. I want you to work out your brain a little bit. I want you to try the last example in your small groups. I'm going to pop about 3 minutes on the clock. Think carefully about where that area sits. I will give you a hint. This involves two calculations. Who can tell me where that middle 60% sits? Drew, you had your hand up first.
Because of the empirical rule, we know that one standard deviation now is 68%. So it's between
68.
It's yeah, between 0 and 1 standard deviation.
Yeah? Good. I agree. If one standard deviation from either side is 68% of the data, we want 60%. We must be just inside those one standard deviation hash marks. Good. We want it centered. If this is 60%, how much is left for my tails? 40 total, 20 each. Good. Cut it in half. So I know that to the left of my lower boundary is 20, or 0.2. How much is to the left of the upper boundary? Eight, yeah. 0.8, because the upper boundary is the red section plus the 20% at the bottom. So 0.6 plus 0.2, there is 80% of the data less than that upper boundary. We need to the left, to the left. This is going to involve two different function calls. Once for the lower boundary that has 20% to the left, and then once again for the upper boundary that has 80% to the left. You will get two different numbers, and you should. I have a number that's a little bit less than the mean on the left. I have a number that's a little bit bigger than the mean on the right. I should get two different boundary values. Yeah? So I'm going to bypass the inverse norm function calls for speed. You did those inverse norm function calls. Who can give me the lower boundary? Katie, what'd you get? 61 point what? How what? 6? Like that?
Yeah. Oh yeah, you can write it.
Okay. Good. Ivan, what'd you get for the upper one?
68.
68 even?
Well, I rounded up. It was like
Oh, it was 67.99. Yeah. Okay. So 0.0. And I'm going to write units on it. We know those are inches. We check if those make sense. That first standard deviation below, was it exactly 61? That's a little bit closer to the mean in 61. Check mark. I know that standard deviation above is 68.6. This is just a little bit less than 68.6. Check. So those make sense. Yay! 0.6 on either side, which makes sense because it is symmetric in the middle. So I would expect a symmetric distance from the hash marks on either side. Yeah, we like symmetry. Yay. Okay, I'd like to give one more warning, and then we're going to be done with notes, and I'll give you some work time. If I could get your attention, this is important. Shh. Okay, on your homework, you will see a couple of questions that are going to give you information about a normal distribution, and they're going to ask you to find the mean or standard deviation instead of the z-score or the data value. It's the same way that we tackled this here. You start with the formula for a z-score, you plug in the numbers you have, you use a little bit of algebra to find the one you don't have. Yeah? In terms of difficulty level of the algebra on the AP test, that is most of it right there. And most of it's going to show up in the multiple choice as like one-off questions. You're going to see a little bit of algebra around working with the z-score formula. That's a big important formula. You'll see a couple questions about the formula for the mean, which is the mean equals the sum divided by the number of data points. Yeah. You can do algebra with those two formulas. Pretty much golden for the multiple choice. There's a little bit coming when we get to two variable data, but not much. Most of this test is calculator math. Yeah. If you encounter those problems on your homework, come see me so we can do some algebra refreshers during tutoring time. Yeah, because this is stats class. I know if you need algebra tutoring, I'm here for it, but we don't have time to take out of the statistics curriculum to do it. So that needs to be an out of class tutoring session. Yeah. Okay. Questions about 1F before we close the chapter on 1F? No.